Let's talk a little bit about illumination. What does illumination mean? How much light is on the scene, right? So when we had the stick figure drawn up here, Steve was drawn up there as a stick figure. That is how much light is on Steve. Scene illumination. Doesn't matter if it's really bright in here and I'm trying to get a picture on the parking deck on the other side. I don't care about how much light where the camera is. I care about how much light is on the scene. Right? That's what I have to worry about. The other thing is indoor versus outdoor. What kind of lights are mostly inside? Fluorescent. Now that's changing, but fluorescent used to be the standard. You had some incandescent, wasn't very energy efficient. So indoor and outdoor lighting is a big difference. Fluorescent and incandescent indoor, now a lot more LED. And then outside, outdoors, you had sodium lighting, high pressure, low pressure sodium. Those are the ones that if you look, I call it like the pink orange dinge. When you're looking out there at the parking lot and the color shifts around and it gets to be crazy, it's like that, yeah, the pink orange dinge. Now, changing again, what's becoming a lot more typical? LED lights. I had a customer call me up the other day and ask me what effect LED lighting had on the camera. And a long time ago, a customer called and asked me that. I said, you know what, I don't know. And then the 7-Eleven, they replaced all their lighting with LED lighting. And magically, the camera continued to make a picture. The key thing for you to remember is lots of visible light helps. Now, there are color shifts in light that will matter as well. For example, when that sodium vapor lighting, whether high pressure or low pressure, it's like you putting on a pair of rose-colored sunglasses, right? You walk out there and things aren't the right color because it provides a tinge or it reflects that light out onto the scene. So constant versus variable lighting. Is the light inside the office change if it's just no windows or a hallway? Constant lit. Whether it's daytime or nighttime, constant lit. What happens at nighttime? If they turn off a certain amount of lights, they still have to have a certain amount on so that you can move through the building safely, right? But a warehouse may not be that way. So make sure you ask those questions when you're out looking and doing surveys. Supplemental lighting, flood lighting, LED lights, or infrared lighting. All this stuff is important. So I've got customers that it's complete darkness out there that they're using infrared light, but if something is detected, they flip a switch and now all of the regular visible overhead light comes on in that area because you don't want to send a police officer out there with a gun to get somebody if he can't see what's going on, right? So the camera sees just great with infrared. Police officers out there like I was stumble around in the field. What is lighting as well as cameras? We talked about that back in that first couple of slides. Deterrent, right? The more lights that's there, that's why they leave all the lights on at the car dealership. It's not so you can go see the cars at nighttime. It's so people don't steal cars at nighttime or break into the cars at nighttime. Right? It's a deterrent. Scene reflectance. If everybody used to have, if you were a photography nut, you had a little tool that was like 2 pieces, and it was a light meter, and you had the part that had the needle on it, typically if you're like a purist, and you had the little other piece that was the measuring or the capturing device. Reflectance is a big deal. I do not, if this is the part that's capturing the light and I'm out in the parking lot over here, I do not walk around like this to see how much light is being put out of the light. That does not matter to me. What does the camera see? What do you see? You see reflections, right? So you have to look at the reflective light. So if I want to see how much light that light is putting out in terms of reflectance, and I want to take a picture of this table, I'm going to hold it like that so that the sensor is looking at the reflected light off of the object. Remember when you were a little kid, anybody do the Olin Mills thing or whatever the photography thing was, and the person always came around with the thing and looked at it, they were seeing how much light was on you. So I want to look at reflected light. I don't want to look at the source light because that number is going to be really high compared to that number. Concrete parking lots are typically what color? White, gray. Asphalt parking lots. What do you think reflects more light?
Concrete.
Right. In the wintertime, sometimes around here we get what? What color is it? How reflectant is it? Crazy reflectant, okay? So keep all this stuff in mind when you're doing it. So if you know that you're walking into an area and all there is like black walls and black boxes, and you know you're going to need more light because of the reflectance, how much light's reflecting back off of the object. So seeing reflectance is a big deal. Know what's out there. Grass is more reflectant than asphalt. Concrete's more reflectant than grass. Okay, if you walk around and see the number of lights, there's a lot of lights around the building. If it's all asphalt, you know it's going to suck up a lot of that light. No light. I want to capture the light in the, I want to capture an image of the stairwell out there. How many people have been here after dark? Now it's probably last night, right? Are the stairwells well lit? I mean, there's probably to a safety standard, right? But as long as they take the bulb, as long as they change the bulb. So my point is, if you're walking around and you are noticing, if you know you have to look at the number of lights, if you're walking around the perimeter of a building and you look up and there's a light every 50 feet on the building, a big giant light pack, how much light's going to be there versus, wow, there's no lights on the outside of this building and there's only 2 light poles, right? And if you see a light pole like at the stadium that's this wide and that high and about 500 lights off of it, you know there's going to be a lot more light than there is of a light stanchion that has 2 lights on it, right? So when you're walking around doing a survey and you're talking about, you know, I want a camera here and I want to see X, you got to make sure there's enough light there. So pay attention to that. Thermal. People talk about thermal, they talk about IR, infrared. Thermal is different than IR. Thermal looks at the differences in surface temperature of objects in the field of view. It makes the same picture at nighttime as it does during the day. Doesn't care. So please keep that in mind. It's just a different kind of, it doesn't care about light. It just looks at the surface temperatures. But during the day when the sun's up reflecting off of something, does the surface temperature go up? So it's going to appear a little different because the sun is heating up the surfaces differently. At nighttime, leaves look a lot different than during the day. What goes on in leaves? Photosynthesis, right? It's just heat. So leaves look a lot different during the day. When the sun's out, they're like a lot brighter in the image than they are at nighttime. They'll be a soft gray. This is that other camera that's out behind the office. You can see, like during the day, constantly lit. Notice how the light changes based on the headlights and the cars going by. How the scene adapts to the light. Now let's talk about some means of supplemental lighting. This is the 180 and the 360 camera in my backyard where there's very little spillover light, where we're using infrared light. This is just floodlights on out basically behind the house. Everybody knows kind of what floodlights are. Even the dog gets more video time than I do. This is black, like you can't see, other than those bright lights that you see through the trees, you can't see anything out there with your eyes.
Is it much different if it's a moonless night versus a...
It is, but I mean, most of the time you want to plan for the worst case.
Right.
This is with that infrared light on, which is invisible to your eye, so you can see what's going on out there in the field of view, but the people walking around out there cannot see anything. This is light that's above the spectrum of where your eyes can see it.
So the same technology as like night vision goggles?
That's more photo multiplying, so that multiplies the light that's there. This is not 850 nanometer light, so it's above where your eyes can see. Bugs love it. Like if you put this out there, bugs are zooming around in front of it, messing with the camera, because they can still see that spectrum of light. I don't know if poor Penny can see it or not, but.
So you wouldn't really get identification with.
Well, you can. I mean, you'll see some other, I don't know if there's some other footage in here, but this light just makes it, it's invisible to your eye, but the camera sees very well with it. The difference is in this specific example, it's a very narrow, or it's a 95 degree flood. So it's things that are really close to it, just like a flashlight, it's going to wash out a little bit. So that's the negative part. But again, just the ability for the thing to see in low light. So here is an image, or this is some footage from a PTZ camera that has a tracking LED illuminator. So this is one that follows the camera. Yes.
Do I use a camera with infrared illumination? Can I use the same camera at a door as I use to look at a field or a parking lot? What if
No,
the
this is my
iPhone
house.
I use is too powerful or not powerful enough? This is Matt Gullicky from Chesapeake and Mid-Atlantic Marketing. My colleague Adam Hadak in Pittsburgh was asked a few questions just like
I'm gonna speed this up a little bit.
Adam Cloud asked to
If
create
I can find my mouse.
with different cameras observing the same scene.
And you'll be able to see some of the difference. So you can still see pretty clearly with that light.
Do you guys have a YouTube channel?
Yes, we do. All this stuff is on there.
So Chesapeake and Mid-Atlantic, is that what it's
I
called?
think it's mid-chess.
Mid-Chess, okay.
But you can see how it's highlighted up at the top with the light, the reflectance. That's back to that reflectance terminology.
I was gonna say it was a shirt.
Oops.
Still washed out.
There's completely invisible to your eye, but with the light on, you can see, you'll be able to identify. You can see all the stuff in the background very clearly. I mean, you can't see any of it with your eye.
That's all the same frame capture rate and everything.
Yep. Yep. I want to go through. This image is thermal versus visible, and there's a little bit of video here that we were asked to look at an airfield. They wanted to see if we could tell the difference between a person and a person carrying a weapon. So this video goes over and shows thermal versus visible versus infrared and stuff like that. It's a really good video that compares all that stuff so you can get a better understanding of it. Some of these documents are available online. Again, you could go to our webpage and download them. We'll send you a link to them on the presentation. There's a bunch of different documents. There's links here to a bunch of different, our YouTube channel, Laurie, and then our webpage, our blog, which is where Matt publishes all these articles. It's kind of an ongoing thing. And then a bunch of other links that can get you to the resources on our webpage.